Today we want to take a look at subsets, distinguishable permutations, and combining permutations and combinations. If I want to take a look at the number of subsets of a set with n elements has 2 to the nth different subsets. So looking at an example of this for number 1, a sandwich shop allows you to dress up your sandwich in any way you like. After you order your sandwich, you can, for no extra charge, add any or all of the following: lettuce, tomatoes, onions, green peppers, jalapeno peppers, or cucumbers. How many possible ways are there to dress up your sandwich? Well, you could have 0 toppings, or 1, or 2, or 3, all the way up to n. So if you are allowed to have anything from 0 all the way up to the total, then you're going to take 2 to the nth. So since there's 6 toppings here, 2 to the 6th would be 64 different sandwich combinations. The next thing we want to take a look at is distinguishable permutations. If we're rearranging n objects and there are repeats, you must divide out the number of repeats. Your repeats may be letters, they may be colors, they may be jobs. So if I take a look at number 2 here, Nicole is playing Scrabble and gets the tiles A, A, B, E, G, G, G. How many different arrangements are there of her titles? Well, if I were to rearrange these 2 A's, it's still going to have the same order, or these 2 G's. So in order to get the different permutations, we want to divide out the repeats. So I'm going to take my 7 letters and rearrange them, which would be 7 factorial, if they were all different. But since I have repeats, I'm going to divide by my number of repeats factorial. There's 2 A's, that would be 2 factorial. There's 3 G's, and so that would be 3 factorial. For question number 3, same idea. A cruise ship has 14 colored flags they can fly while cruising. If there are 4 pink flags, 3 green flags, 2 blue flags, and 5 yellow flags, how many different arrangements are possible? If I switch the order of 2 of the pink flags, it's still the same order. If I switch the order of 2 of the green ones, or all 3 of the green ones, it's still the same order. So we have to divide out our repeats. In this case, I'm going to take all my possible combinations, 14 factorial, and divide by 4 factorial, 3 factorial, 2 factorial, and 5 factorial. If you are doing this all in one set in your calculator, do make sure that you put parentheses around your denominator. For question number 4, now we want to know how many 4-digit numbers contain no 3's. My 4-digit numbers start at 1,000 and go up to 9,999. The first number has to either be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. Remember, a 4-digit number does not start with 0. So if I don't have a 0 and I don't have a 3, then there would be 8 possibilities for the first spot. Then there would be 9 possibilities for the second, 9 possibilities for the third, and 9 possibilities for the fourth, because I can have any of the numbers 0 through 9, which would be 10 digits, but not 3. So that would give me 5,832 4-digit numbers that do not have the number 3 in them. For part B, it says how many 4-digit numbers contain at least 1 3. I'm going to take the total number of 4-digit numbers, which would be 1,000 to 9,999, which would be 9,000 numbers, and I'm going to subtract out all of the numbers that don't have a 3. So if I just subtract out the ones that don't have a 3, that's going to leave me with the ones that have at least 1 3.